Oh, Rabbit, why are you being so dramatic?
I'm just out of breath, Dragon.
Why?
Well, you told me walking to your house was gonna be 60 steps, and it took me 180 steps.
Nonsense, Rabbit. I walked to your place yesterday and it was exactly 60 steps for me.
But it's not, Dragon.
Are you calling me a liar, Rabbit? I don't like being called a liar, Rabbit. When someone calls me a liar, Rabbit, I get very angry.
Uh-oh.
And when I get very angry, Rabbit, I blow fire.
Is it getting hot in here, or is it just me? Comparing bigger units and smaller units of measurement today on Teaching with Mr. H4. Hey there, math extraordinaire. It's me, Mr. Hernandez, aka Mr. H4, aka Mr. Not Really Blonde. I know, we're all so shook. And today, I'm here to welcome you to this fabulous world of measurement as we compare big units and small units. So let's head over to my classroom in 3, 2, 1.
And I want to bring up the context of the video earlier. So it takes Dragon 60 steps to get to his house from Rabbit's house. It takes Rabbit 180 steps to get to Dragon's house from Rabbit's house. If they walked the same distance, why did this happen? Why was one bigger than the other? And this is one of the big reasons I wanted to film this video, just to understand this concept. So the green house is Dragon's house, the blue house is Rabbit's house. It takes Dragon 60 steps to get to his house, and it takes Rabbit 180 steps. But you're probably thinking, like, that's impossible. Well, that's probably because we think on such defined terms, because if they were using a standard unit of measurement, they would be measuring with the same thing. If Dragon measured with feet, then he can tell Rabbit how far his house is, and if Rabbit was measuring in feet, it'd probably be the same thing. But the fact is that their steps are different. Dragon has bigger feet than Rabbit. Rabbit has smaller feet. Now here's my question for you. How did I know that? How did I know Dragon had bigger feet? How did I know that Rabbit had smaller feet? Think about it for a second and we'll be right back.
525,600 minutes. How do you measure a year? Well, must have not been a leap year.
Sometimes when I'm working with bigger numbers like 60 and 180, I like to break it down to myself by using a smaller number. So let's just think of it in this context. If I have a desk and I'm deciding that I have two different units, and the two different units I'm going to use are pink ellipses, and I'm going to use, or pink ovals, and I'm going to use blue circles to measure this desk. They're two different units, and I'm measuring the same desk. That's very important. Problems like this, you need to make sure that you understand that this is the same desk. It's the same distance across. So I'm going to take my pink ovals and I'm going to put them across. And what do I notice after I measure my desk with my pink ovals? I notice that my desk is 1, 2, 3, 4, 5. 5 pink ovals long. Now I'm going to take my blue circles and I'm going to measure the same desk. The size of the desk has not changed. The size of the desk is going to be the same no matter what. But what I use to measure it is probably going to change. So check this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It took me 15 blue circles to measure the desk. My question here is, did the desk get bigger while I was measuring with the blue? No, the desk didn't get bigger. The desk wasn't smaller a second ago with the pink ovals. Right now in my brain, I'm like a little confused, but I don't have a lot of pink ovals and I have so many blue circles. So the blue circles has to be more. Well, the fact is the desk is the same size. So 5 pink ovals is exactly going to be the same as 15 blue circles. And when I look at it through this context, I can notice something about these units. I notice that the pink ovals are bigger than the blue circles. And because the pink ovals are bigger than the blue circles, it took me a faster amount of time to measure the desk because I'm covering more space in less amount of time when I'm measuring with something bigger. When I'm measuring with something smaller, I'm covering a lot less space when I'm measuring it. When I'm measuring with something big, I'm covering a lot of surface area all at once. So that's why with the pink ovals, it took me faster and I got to use less of it. And when I had the blue circles, it got me there a lot slower and I had to use more of it. Because a bigger unit will cover more surface area and a smaller unit will cover less surface area. So this brings me to a conjecture, which is a fun way of saying a math rule that you probably want to take and slip into your pocket for future reference. That the bigger the unit, the less of that unit you will need. To measure a given distance than a smaller unit. And this is also true for the inverse. The inverse of this, let me put my pink stuff right there. The inverse of this being smaller the unit, the more of that unit you will need to measure a given distance in a bigger unit. I think where you see a lot of children, I'm trying to draw my little line. It's not letting me draw a line. Oh, that's because I keep pressing Control. Wrong button. A lot of children will get lost because they see the number 15 and in their brain they're like, 15 is such a bigger number, so that has to be a bigger unit. When in actuality, 15 is the amount of jumps it's taking to go from one side to another side. 5 is the amount of jumps it takes to go the same distance for something else. And if they can bring it to the understanding of getting from one side of the desk to another side of the desk faster, it can really help them understand, how did you get there faster? Well, I took bigger jumps. What are those bigger jumps called? Those bigger jumps are called a bigger unit. What are those smaller jumps called? The smaller jumps are called a smaller unit. So sometimes it really helps to bring into perspective of jumps that they're taking and the amount of time it's going to take you to get from one side to the other, to understand this relationship we have with bigger units and smaller units. Now, we can think of
How tall I am? Well, I like to tell people that I'm 6 foot, but if you count my hair, good 6'2", 6'3" on a good day.
And yes, we have returned back to our original problem. So it takes Dragon 60 steps to get to his house from Rabbit's house. It takes Rabbit 180 steps to get to Dragon's house from Rabbit's house. If they walked the same distance, why did this happen? So I know Dragon took 60 steps, Rabbit took 180 steps. The distance between their two houses, let's pretend these two cans of seltzer are the houses. This is never going to change, walking back and forth. But one person took 60 steps, another person took 180 steps. How is this possible? Well, Dragon's steps were bigger. He had a bigger unit than Rabbit. And the reason why we know this is because he needs less steps to go the same distance as Rabbit took. So since Dragon takes bigger steps, a bigger unit, he gets to his destination a lot faster. If I thought about this in the inverse, I know that Rabbit takes smaller steps than Dragon. I know this because he needs more steps to go the same distance as Dragon. Since Rabbit takes smaller steps, a smaller unit, he gets to his destination a lot slower. If you need a little bit more help with this, think about yourself running a race. So you and your friend were running a race and we're running against each other. If you're in a race, would you want to take the least amount of leaps to the finish line, or would you want to take as many steps as possible to get to the finish line? Think about that, and we'll be right back.
Hey everyone, I want to introduce you to my biggest fan.
So in review, the bigger the unit, the less of that unit you will need to measure a given distance than a smaller unit. And smaller the unit, the more of that unit you will need to measure a given distance than a bigger unit. And why is this understanding and thinking about things through steps and ovals and circles even important? Well, it helps you understand the need to have standard units of measurement and how those units even relate to each other. It's important that we have standard units because we need a unified unit to help us understand. I want to make sure that I'm giving my friend the same unit, or if I'm going to the store to buy a rug, I'm giving them the very specific, defined unit that I'm going to need to fill the space that I need. It's not going to be an estimate based off of like my foot versus their mom's foot. If we didn't have standard units, we'd be all over the place in our thinking about how big something is. And there'd be a lot of confusion in this world. And they also teaches us this concept of bigger the unit, the less of it you will need, smaller the unit, the more of it you will need. Helps us understand when we think of inches versus feet versus yards. Inches is a small unit, feet is in the middle, yards is a bigger unit. I know 12 inches equals 1 foot. I know this relationship that 36 inches equals 3 feet equals 1 yard. And sometimes when you're looking at all these different numbers, you're like, but 36 seems like such a big number. Yes, but it's because it has a smaller unit. 1 is such a small number. Yes, because yards is a big unit. 1 inch, 1 of a small unit, is not going to be anywhere near 1 yard, 1 of a bigger unit. I just drew this example over to the side just to show us how 1 yard is a lot different than 1 foot, which is going to be a lot different than 1 inch. So we want to clearly understand this relationship of how units relate to each other. If I have 36 of a big unit, that's going to be a lot bigger than 36 of a smaller unit. With that being said, if I'm measuring something, I can clearly understand why, oh, this is 36. Well, that's the same size as, this is 36 inches. Well, that's the same size as something that's 1 yard. That totally makes sense to me because we're not only looking at the number of our measurement, we need to be looking at that unit because unit is clearly defining the amount of space that's being taken up.
And there you have it, folks. And if you liked what you learned today, please subscribe to my channel, and I'll see you next time.